Warm greetings to all. I am AK Mittal. I am associated with TSDSI as an advisor, and on behalf of TSDSI, I extend warm welcome to all the distinguished panelists, speakers, the co-chairs, and the distinguished participants of this session. Uh, Two of the ongoing TTDD conference, fourth edition. This conference is graced by renowned speakers from India and abroad, and also the participants from India and abroad. As you know, the title of the session today is Vision for 6G, Requirements, Use Cases, Applications. It's going to be a very interesting and engaging session. We hope so. And please participate. Request you to participate, actively, ask questions. The session starts at 10:30. We have started, and the end time is 12:45. We will try to keep time of all the parts of this session and this uh, right. The session is co-chaired by Mr. Satish Jamadagni and Professor Kiran Kuchi. And let me briefly introduce you to Mr. Satish Jamadagni and Kiran Kuchi. Their detailed bio is available on the TTDD website. So, Mr. Satish Jamadagni first, he is currently the Vice President and Head of Standards in Reliance Jio. He has 23 years of industry experience in telecom domain. He is also the current Vice Chairman of TSDSI and previous chair of TSDSI Working Group Study Group Networks, which was responsible for creation of standard 5GI. Then I introduce you to Professor Kiran Kuchi. He is a professor at IIT Hyderabad, and he is a globally recognized innovator in the realm of 5G standards development. He has invented and co-invented over 100 patents in 4G, 5G technology, of which more than 50 patents have resulted from his work carried out in India. And I just forgot, missed that Mr. Satish Jamadagni also has a number of patents to his credit. So we have distinguished co-chairs here. Now I hand over to Professor Kiran Kuchi to introduce you to the session and to the keynote speakers. So over to you, Professor Kiran Kuchi.
Thank you, Mittalji. Uh, Thank you for your introduction. Can you all hear me?
Yes, you are loud and clear.
So, just to say a few words before we get started with the presentations. 5G has already undergone 3 releases, release 15, release 16, and release 17 soon to be published. So 5G standardization is more or less a near complete activity, which started, quite some time back. IMT 2020 was the name of the program for 5G as per ITU. And we are already into 2021, and ITU looks ahead about 10 years ahead in the definition and the development of these global standards. So it is time to have a serious conversation about IMT 2030, aka 6G. These are the general names assigned to 4G, 5G, 6G. These are all commercial names attached to the IMT process. IMT 2030 is something we call 6G. I'm also happy to note that TSDSI has taken a very strong initiative in the development of 6G requirements and use cases, taking the cue from ITU. So, as part of these 6G deliberations, TSDSI has initiated this event in this deep dive conference, and we have very well-known and reputed experts selected or invited to represent different regions. We have 3 talks, excellent ones, coming up, and followed by that there is a panel discussion. And these talks combined with the panel discussions will address the 5G requirements, use cases, the various technology early developments and serious developments happening around the world. So it must be interesting to those who are very keen about 6G. And let's get started and hear from the experts. I'll be happy to get started with the presentations now. Mittalji, should we start now?
Yes.
Okay.
Just presentation will be coming up. Yeah. So this is.
So should I introduce this first speaker, Mittalji?
Yes. Yes. His bio is here in front of you, Mr. Juho.
Okay, great. So thank you all. The first presentation is by Dr. Juho Lee. I have known Juho for a number of years, working very closely with him during 5G standards definition at 3GPP. He's a very well-known expert in this radio communication technology development, and we're very happy to have him. Lee is currently a fellow with Samsung Electronics, where he's leading the research and standardization. He joined Samsung Electronics in the year 2000, and he has contributed to a number of wireless technologies, including 3G, 4G, and 5G. He's also leading the 5G evolution inside Samsung. And he was vice chairman of 3GPP RAN 1 during 2003 and 2009. And he's a known expert, and he has a PhD degree in electrical engineering from Korea Advanced Institute of Science and Technology. And Juho is also a fellow of IEEE. It's our privilege to invite Juho and have his presentation initiated, and he's also here to address any questions after the presentation. Thank you, Juho. We'll get started.
Hello everyone, my name is Juho Lee. I'm leading research and standards for mobile communications in Samsung Research, Samsung Electronics. Today I'm very pleased to share our initial thoughts on 6G. So 5G commercial networks have been deployed in 68 countries by 162 operators since April 2019. And there are 389 million subscribers globally. So this data is as of Q1 this year. So you can see that 5G networks have been actively deployed. So in terms of performance requirement, 5G was designed to provide much higher performance than 4G. So in terms of peak rate, 5G can provide 20 Gbps. In terms of latency, it can provide 1 millisecond latency. In terms of number of devices, 1 million devices per square kilometer. So all in all, 5G can provide much higher performance than 4G. And these can be characterized by ultra-fast, or in other words, enhanced mobile broadband, instantaneous or ultra-reliable and low latency communications, and the machine motion type communications. So cellular communications has been quite successful since 3G based on a global standard. And 4G also was very successful, and it triggered IT and communications convergence and global competition between many players. So customers could take benefit from that. And as said before, 5G was designed to enable major 3 use cases: EMBB, URLs, and massive MTC, also based on standards. And in average, we can consider that in every 10 years, new generation was created for mobile communications. So likewise, we expect that 6G will also be developed based on global standard, and it would take place around 2030. So this is very right time to start initial research and consideration for 6G. So what is really moving us towards 6G? This might be a complicated question, and it may take a longer time to have proper answer. Nevertheless, it is worth considering kind of mega trends which we need to take into account to prepare for 6G. So number one, as we now see that new form factor devices are happening, like AR glasses and VR headsets, and of course those are taking benefit from 5G cellular communications. And in the future, we expect that hologram devices could also happen. So these are typical examples of multimedia services for human beings. In addition to these traditional multimedia services devices, we expect 500 billion devices will be connected by 2030, including vehicles, robots, home appliances, etc. So 500 billion machines or devices actually are corresponding to about 60 times the world population. So this is a clear indication that we have to consider connected machines as main users in designing 6G systems. And the second megatrend is AI/ML. So AI/ML is being already used as a new tool for wireless communications in order to improve performance as well as to reduce cost of network operation and installations. So for example, the base station size can be optimized by using AI/ML, and the network parameters can also be optimized with that. And the AI/ML can be used to monitor network situation and also to prevent potential problems. And in case some critical problems happen, AI/ML can be used for root cause analysis. And the AI/ML also can be used to optimize network energy consumption by taking into account traffic situation and also consider the optimal use of frequency sources and the various resources. So it is very clear that AI/ML are already being used for optimizing various problems in 5G. On the other hand, AI/ML has not been considered for designing 5G system from the beginning. So we think this can somehow be further improved in 6G so that we can have some holistic view for use of AI/ML in 6G. So this is second megatrend. And the third megatrend is openness. That is open source and open interface. So software-based implementation of networks are becoming more and more important and quite essential. So it is all because of the performance improvement of CPUs and GPUs. And this software-based implementation enables wide utilization of open source-based implementation, and also it results in more need for having open interfaces among different network entities. And this trend will be more significant in terms of, in the 6G time period. And the last but not least, we consider social goals and mobile communications as another big mega trend. So mobile communications can contribute to reducing greenhouse gas emission and also improving education inequality by providing hyperconnectivity to everyone. So taking into account all these megatrends, moving us to a 6G, we have a dream of providing next level of hyperconnectivity in every corner of our lives. So in a simple phrase, our 6G vision can be said that the next hyperconnected experience for all, as written here. So as a representative of new services, we consider truly immersive XR, which is basically kind of integration of virtual reality, augmented reality, and mixed reality, and other further improvements. And high fidelity mobile hologram, and the digital replica, as you see here. So with these new services, we want to move forward to the next level of the connectivity, hyperconnectivity. And we also would like to enable quite new services, of course. Then these will require much higher performance requirements than 5G. So for example, in terms of peak rate, 1 Tbps can be considered, which is 50 times of 5G peak rate. And user experience data rate of 1 Gbps, 10 times improvement compared to 5G. And latency of 100 microseconds, which is again 10 times improvement compared to 5G. And there, of course, can be other performance requirements. So it is a quite initial phase. So we expect that many researchers and companies, players have to spend more effort and time to reach consensus on performance requirements for 6G in the future. So this is a very early research phase. So it's very hard to say what technologies will be used for 6G. Nevertheless, we have initial list of candidate technologies in our mind. So this shows an initial list. So terahertz band and antenna technology, duplex technology evolution and comprehensive AI, network topology evolution, intelligent spectrum sharing, split computing, and high precision network. So I'd like to talk about some of these today. So terahertz technology. So as cellular communication generation evolves, the spectrum range has been expanded, as shown in this figure. So in case of 4G, approximately up to 6 GHz, and 5G up to 110 GHz. And with 6G, we want to go beyond 110 GHz, like sub-terahertz or terahertz band. And sub-terahertz band includes enormous available bandwidth for potential 6G services. So by utilizing more wider bandwidth, we can provide much higher performance than 5G. And in addition to the data service, terahertz also can provide high precision positioning and sensing capability. On the other hand, this very ultra high frequency naturally gives us many technical challenges. For example, the path loss will be much severer than before, and the RF power amp efficiency is another hurdle, and even ADC-DAC needs to operate very high speed, so it is giving us another problem. So we are working very hard to overcome all these technical challenges. As a part of our work, we are doing terahertz POC. We are utilizing 140 GHz frequency band, and we are implementing 128 element antenna arrays. And we have been doing some performance tests while keeping the 50-meter distance between transmitter and receiver. And in the next slide, we are showing a short video clip this shows how the adaptive beamforming operates at the receiver side. So receiver hardware is physically rotating like this. So the direction of the antenna panel varies according to time. Then you can see that the data rate is maintained around 6 GHz. So this clearly shows that adaptive beamforming works well. So it is feasible to apply adaptive beamforming for terahertz band with the antenna arrays. And the next technology in our mind is antenna technology evolution. So MIMO technologies have been quite essential in 4G and 5G. And we would like to consider metamaterial-based technology to further enhance beamforming and signal propagation, which is more important, especially for terahertz band, as well as millimeter wave band operation. So with the metasurface lens, we can adjust beam direction by applying DC bias to the constituting elements of metasurface lens. As you may know, this metasurface lens consists of quite many number of elements, and we can further control the beam direction and the beam sharpness using this lens. And the second approach is the so-called reconfigurable intelligent surface. So in case, as shown in this figure, because of buildings, for example, in case you cannot have direct propagation path, line of sight path between base station and the devices, it is very hard to operate terahertz signal or millimeter signal. So then in that case, the base station can transmit signal to the RIS, then RIS can reflect those signals to the target devices like car, mobile device, etc. So this RIS can be quite useful to further widen the applicable cases of terahertz band operation. And the next one is Duplex Technology. So traditionally, FDD or TDD has been used. And with these technologies, downlink and uplink signals are transmitted, as shown here, using non-overlapping sources or in a mutually exclusive manner. With the full duplex, we allow overlapping between downlink transmission and uplink transmissions. So we can achieve 2 times improvement of data rate in theory. It has many technical challenges, so we may need to have more time to overcome all these challenges. As an intermediate step before moving forward to full duplex, we are considering a technique called XDD in our terminology, which is kind of cross-division duplexing. That allows simultaneous use of a single TDD band between downlink and uplink transmissions without overlapping between them. So by doing so, we can provide continuous uplink transmission, as shown here. Then we can improve uplink communication coverage a lot, and also we can reduce overall latency in TDD band operation. So this is showing how we have done the performance test for full duplex operation at millimeter wave band. We had a 100-meter distance between base station and the mobile terminal. And we did a throughput test. So as you can see here, full duplex provides about 2 times data rate compared to time division duplex. So even though there are many hurdles for self-interference cancellation, we see a good possibility of overcoming those in practical networks. We actually implemented antenna level SIC and digital level SIC operations, and we achieved these performance results. XDD. So as I said before, as an intermediate step, we propose XDD for inclusion in 3GPP Release 18 standard for 5G advanced. Our motivation is to, as I said, to improve uplink coverage. And if you consider the main reason for coverage reduction with NR, the use of TDD operation in higher frequency band like 3.5 GHz and 20 GHz band, this combination of TDD and the high frequency spectrum results in quite much reduction in cell coverage, especially for uplink with TDD. So with the concept of XDD, we can allow continuous uplink transmission like this, so that the uplink transmission and uplink received energy is improved a lot, and then we can improve uplink coverage, and also we can improve overall latency. So next one is AI/ML for communications. So AI/ML can be used for improving various aspects of 5G networks, like network planning and problem detection and self-healing of network anomalies, and the network management and performance improvement, such as handle optimization, scheduling enhancement, etc. But anyway, all those examples are kind of application of AI/ML for individual problems. So there has been no holistic design of AI/ML together with the 5G communication systems. So in 6G, we would like to have comprehensive and native AI support, in a sense that we can have end-to-end optimization of the overall system operation. So evolution of network topology. So in 4G and 5G, relay and IAB were introduced, and with 5G, many companies are considering the use of satellite components like NTN. And in 6G, we think all those different entities have to be considered from the beginning. So we have released our white paper on 6G last year, so please check this if you have interest. So that's it for my talk today. Thank you very much for your attention.
Thank you, Juho. This is excellent information and a very good talk. Juho, can you hear me?
Yes, I can hear you.
Excellent, excellent. So good to see you.
Hi.
So perhaps we can take some questions, Juho, from the audience.
Yeah, sure.
Okay. Let me see where the questions are. Give me a moment. Akanksha, do we have some questions? Q&A, let's see. Okay, so first question, perhaps we can go with, what are 5G limitations that prevent application of meta surface lens and RIS?
All right, that is a very good question.
Yeah.
Simply speaking, the majority of those technologies, meta surface or such lens type, reflection, their maturity level is not high enough so that they can be utilized in 5G networks. And when you started the 5G standardization, actually those technologies were not available yet. It was the initial phase of doing research on those technologies. So it is kind of late to utilize those technologies in 5G, but we think it is very high likely that those can be used for 6G because we can consider them from the beginning in designing overall 6G concept.
Okay, good. Thank you. There is one more question. What's your take on new modulation technologies for 6G other than OFDM and OFDMA?
Yeah. Again, thank you very much for good question. Excellent question. Actually, we had similar question already when we started 5G work. As some of you may remember, there were multiple other proposals on the table, but then eventually Ofdm was selected, and also DFTS Ofdm was selected. So yeah, perhaps we can overcome all these technical challenges we observed with other technologies in designing 5G. Then maybe we can consider other modulation schemes for 6G, but it's very hard to say what other modulation schemes we can use for 6G yet. So please wait. I hope I can come up with good news in the future.
Okay. Thank you. One more question. As we are moving to higher frequencies in 6G, what are the methodologies that may help in overcoming the coverage challenge?
Yeah, so basically there's no magic. So we have to rely on the kind of antenna array, utilizing quite many number of antenna elements. So as you saw in our this short video clip for Tails POC, currently we are using 128 antenna elements, and we may use more antenna elements in the future for 6G. Or in addition to that, we could use combination of the so-called meta-surface lens and the traditional antenna array. Then we can have more sharpening of the beams and better control on the beams, and also better control, better concentration of energy level. So yeah, we are looking at those possibilities.
Excellent. What kind of 3GPP standard impacts do you see when AI/ML is introduced for physical layer? I mean, it should be read as if not when, if or when.
This might be kind of disappointing people who are doing research on AI/ML algorithm itself, but we don't expect AI/ML algorithm itself will be specified in standards. Instead, sort of kind of supporting mechanisms, for example, some signaling elements or the overall operation of network and terminals may be specified. Then inside those implementations of base stations and terminals, there will be some AI/ML algorithms. But then, of course, in order to have good hints on what really needs to be specified, we need to have good understanding what AI and ML algorithms are doing. So is it a good answer?
Yeah, I think that's good. What is the tentative launch schedule for 6G?
You mean the schedule for the 6G?
Yeah.
Yeah, so we expect around 2030 6G will take place. Originally, we thought that 6G could take place earlier, for example, 2028 at earliest, because when you look back the history, the time to develop new generations has been kind of shortened over releases or over generations. But then we got this COVID-19 pandemic situations, and everything has slowed down, and there seems no good motivation why you have to introduce 6G so early. So we expect that 6G will take place around 2030. So it is about kind of 10-year time difference compared to 5G.
Yeah, thank you. So one more question. With terahertz, the coverage is limited. Do you foresee usage of hybrid centimeter waves, millimeter waves as part of up to terahertz?
Sorry, I didn't get your point. Can you say again?
With terahertz coverage being limited, do you foresee usage of hybrid centimeter waves, millimeter waves, and all as well?
Yeah, sure, of course. I mean, basically, Terahertz cannot provide global coverage, I assume, and I think everyone should agree to that. So for 6G, even sub 1 gigahertz can be used, for example, 800, 900 megahertz, and 1 gigahertz spectrum band, or 2 gigahertz and 3 gigahertz, 3.5 gigahertz band. All those available frequency spectrum that are being used by 3G, 4G, and 5G will also be used in 6G timeframe by 6G concept. So we can use all these different combinations of terahertz band, terahertz waveform, and the millimeter wave band, and centimeter band, and others. Yeah.
Okay, so I will ask you one question myself. If the aim is to really move towards much higher frequencies, then you could possibly define a new radio interface technology for those new high frequencies. But will there be a motivation to define a new radio for frequencies below 100 gigahertz, which 5G already has?
Yeah, so actually I want to emphasize that terahertz is not the only thing for 6G. We are considering terahertz because we always would like to expand the frequency resources, spectrum resource we can use for our communications. So it is a natural choice to explore opportunities with terahertz band. On the other hand, low frequency spectrum is always important to have global coverage. And over time, I'm sure we'll find new applications, new services. I mean, we are saying XR, mobile hologram, and digital replica, etc. Of course, all those would require higher data rates or higher bandwidth. So perhaps terahertz may be attractive, but still millimeter wave band also can be used for such purposes, I assume. And for others, for other services requiring lower data rate can still use lower spectrum band because they can use smaller bandwidth. So I'm sure over time you'll find the new services applications that again motivate developing new air interface also for low frequency spectrum.
Thank you. We'll have to stop here. Thank you, Juho. Excellent talk. Thank you for all the answers. Hope you can stay around and we'll move on with the program. Thank you.
Sure. I'll stay here. Thank you.
Bye-bye. We will move on with the second talk. Let me just pull up the information. Mittalji, can you display the introduction for the next speaker?
Yeah. Akanksha will just do that. Yeah. Akanksha, can you display the bio of next bio?
Now, while it's coming up, let me introduce our second distinguished speaker, Ian Sharp, who is a principal technologist at Atis with an interest in the area of mobile networks and their evolution. Within Atis, he is responsible for leading activities related to 3GPP, where he previously served as vice chair of CT Plenary. He holds several patents for mobile technology. Welcome to TSDSI Deep Tech Dive, and we're very happy to have you in Sharp. Please, let's get started. We would like to hear your views on 6G. Thank you.
Hi, this is Ian Sharp. I'm Principal Technologist at Atis, and I'm delighted to have the opportunity to talk to you today about the NextG Alliance, which is an Atis initiative building the foundation for North American leadership in 6G and beyond. So let me start off by giving you a quick introduction to Atis, and then we can talk about the NextG Alliance itself. So for those of you who may not be aware, Atis, or the Alliance for Telecommunications Industry Solutions, is a standards development organization and industry group based in Washington, DC. And we have a particular focus on the North American marketplace, as well as a range of international activities. And we're really very focused on advancing the ICT industry, particularly at the transformative technologies which are beginning to reshape the industry. One important activity and relevant to this discussion in Atis is we are the North American organizational partner for 3GPP. So we are really the pathway for North America to participate in that global activity. And of course, we have very much welcomed the partnership with TSDSI as a recently joined 3GPP partner themselves. Beyond that, we have a range of technologies looking at, for example, very topical issues like security, identity, and privacy. Also looking at Internet of Things and the use of mobile networks for smart cities and other applications. So let me talk to you a bit more about how we approached the topic of 6G in Atis and how that brought about the creation of the NextG Alliance. So when we looked in detail at what was happening in 6G, and a couple of important observations came out of that. One was that we, in the North American region, we had a lot of interest from policymakers in what was happening in 5G and beginning to recognize the importance of 5G as a strategic technology. But outside of a kind of fairly small group of technically focused people, there wasn't a lot of recognition that we were beginning to enter the sort of critical time frame when 6G was going to be an important topic. So one thing that we recognized that we needed to do was to really raise the profile of 6G and put that alongside 5G as a topic of interest. Then I think the other thing that we observed, which is that in the 6G era, all the main regions recognize that having a strong technical input to the definition of standards for the mobile generation is an important activity for their region. And that's, of course, that has to go alongside the recognition that there is a lot of value in having global standards. But equally, we want to make sure that all regions are well represented in any global activities towards the next generation. So out of that, Atis put together a document, a call to action document called the Path to 6G. And that was something that we distributed widely and discussed with both policymakers and industry in North America. And out of that, we got sort of specific feedback, which led us to form the NextG Alliance starting in October 2020. And that feedback really led us to have a private sector initiative, so using industry and Atis as an industry focus to bring that organization together with the intention of both sharing information within the industry, but also influencing actions and direction of government thinking and thinking in research communities. I think it's fair to say this has been an extremely well-received and successful initiative. We have quickly grown to over 75 members from industry and academia. And as I'll talk to you shortly, we're also beginning to open up the Alliance to direct participation from governments. The technical work has been progressing for several months now. And we have over 500 experts participating in different groups, looking at not just NextG technology, but a range of topics related to NextG, which I'll talk to in the coming slides. So when we set up the NextG Alliance, what were really the key goals that we had? One of the first things that we saw as very important was to have a national agenda for the next generation. In North America, the historic pattern for previous generations has been to have a very industry-led and bottom-up-led approach to defining generations. But we recognize that we have to sort of see this more holistically, and we obviously want to have industry leading the activity, but we need to put that into a framework where we have a full agenda, and we'll talk about the need to see that in a complete life cycle model. Secondly, we want to position North America for success, and that means having the right technology, making sure that we understand the R&D needs, making sure that we understand our standards goals and how we bring the next generation technology into a successful market position in North America. And lastly, we wanted to position North America to be a leading market for the next generation. So that really is about having a position in place in the market where the next generation can be deployed, and not both as a domestic technology within North America, but also North American organizations can be major players in globalizing 6G. So in order to do that, achieve all those goals, what we wanted to do was to take what we call a whole life cycle approach to the next generation. And the importance here is to not just focus on technology or standards, but really to see what's happening in the next generation in a broad perspective. At the top of this slide, you can see the sort of main organizations that we're working with. So we have the US government and funding agencies on the left, and the Next G Alliance with our large and broad participation on the right. And these are collectively feeding into the activities shown on the bottom part of the slide. And on the left, we have sort of some of the typical technology pieces associated with any generation. So having the right research pieces, making sure that we are incentivizing companies to invest in the research and the standards activities associated with the next generation. And then also, of course, making sure that we have a role in standards leadership. And it's important to point out that the goal of the Next G Alliance is not to be a standards organization itself, but we are aiming to influence the standards process. But then we also see some longer term goals in the life cycle of the next generation. So, for example, having the marketplace ready to accept 6G, be that in terms of, for example, spectrum policies or policies relating to being able to build out networks. And, how do we develop networks that can be deployed into rural environments? And also making sure that we have the right policies in place that we can move the next generation from a technology activity into a market activity quickly. And that could involve having trial networks or test beds, making sure that we have the right kind of workforce skills, and potentially also educating end users about the technology. As I said, the activity has been extremely well received. Our founding and full members represent the major providers of mobile services and their suppliers, whether that's equipment or integration suppliers. And as you can see, we have a very broad and diverse set of companies there. We also recognize the importance of the broader ecosystem, and the contributing members represent organizations that are involved in other aspects of the mobile technology community, and also academia. And you can see here that we have a lot of interest from academic institutions who are really very active in research related to next generation. When we originally set up the Next G Alliance, we saw it as being very industry-led and liaising with government, as we showed on the previous slide. I think what we've learned in the process of bringing this to this stage is that there is a strong interest in government being directly involved in some of the activities, and government is a major user of mobile technology as well as a regulatory organization. So we are in the process of bringing government agencies into the Next G Alliance, and I think that will further deepen and expand the participation of the group. We have been very lucky to have extremely strong and skilled leadership within the Next G Alliance. Within the sort of full member group, we have leadership from AT&T and Ericsson. And then we have 3 co-chairs from Nokia, AT&T, and VMware for the steering group. And I think one of the pleasing aspects of this is that we have, as you can see, a variety of different interests represented here. So we're not just working with traditional vendors or traditional operators, but really bringing some of the new and innovative thinking, as well as the strengths from these very important organizations that have traditionally been involved in mobile technology into the group. As I said, the group has grown extremely quickly, and there is already a lot of technical work happening. And in order to bring that and make that efficient, we thought it was important to have a technical program office. And we were interested in the opportunities of working with an academic institution to provide that role. And we're very pleased to have established a relationship with Virginia Technology Applied Research Corporation to act as the technical program office. And Eric Berger, their director, has been, I think, an influential person in laying out some of the North American thinking around next generation technology leadership. And so that organization is not only providing support and coordination between the Next Generation Alliance activities, but also helping connect the Alliance into the broad research activities happening in US-based and North American academic institutions. So one of the key activities that we're undertaking is to develop a North American 6G vision, and this will be one of the first deliverables that will come out of the Alliance. And we want to make sure that when we work on these topics, we look at the whole breadth of the questions that are relevant. And so at the bottom of this chart, we have sort of typical technology development activities. Many regions have their own approach to doing that for the next generation. But we're also looking at applications and markets. And there is a lot of, for example, interest in what are the novel applications for the next generation. How does this play into things like augmented reality? What are the opportunities of maybe some of the advanced positioning technologies that will come with the next generation, and also the national imperatives. So what is really the importance of the next generation for the countries in North America, and what do they need out of the next generation that is maybe not so well fulfilled by the current generation. So I just mentioned this, the national 6G roadmap is one of the early deliverables. I mean, we have already created some input, for example, to the ITU process, but I think this is going to be a really interesting document looking at the complete journey towards the next generation over the next decade. And this will be available early next year. And looking at, as I said, some of these broad topics, obviously standards leadership and the technology areas, but also, what are we recommending in terms of research funding? What are we recommending in terms of government actions and policies to prepare for the next generation? So lastly, I just wanted to perhaps give you a bit more insight into the technical working groups. Obviously, the role of the National 6G Roadmap Group is to bring together all the pieces that are going to contribute to the roadmap we just talked about. The technology group has been very active with, I think, over 50 different technology elements being considered as part of a potential part of the next generation. The goal of the applications group is to really dig into the applications, and I think we're seeing a lot of innovative thinking there, coming at this not from what's technically possible, but what could be developed as a new application. I think the societal and economic needs group is taking the important role of looking at how the next generation addresses social needs. And, you know, obviously North America is a very well developed marketplace, but it still has extensive rural areas, for example. And so how do we use the next generation to address some of those interests of those groups? Any mobile technology, I mean, Spectrum is a key part of that. North America has been quite innovative in Spectrum thinking, for example, with the rollout of CBRS. And so we want to kind of looking at what is going to be the Spectrum technology. And lastly, I think by the time we get to next generation, environmental issues are going to be even more important than they are now. And so how do we decarbonize the network, and how do we reduce its environmental impact overall? And the Green G group is really taking very strong leadership in looking at those issues. So I think that kind of gives you a good introduction to the Next G Alliance and our immediate deliverables. If you're interested in more information, or you're interested in joining, then please do consult the website. And I would be very pleased to try and answer your questions during the Q&A session. So thank you for your attention.
Thank you, Ian. We will take the questions at the end of the next session, after the next speaker, if it's okay with you. And let's move to the next talk by one of the distinguished speakers, Satish Jamadagni. Methodology, can we project the bio of Satish?
Satish, and you have been introduced, so we straight away go to the presentation.
Great. So I think we can, go to the presentation right away. Satish, welcome. Let's get started. Thank you.
Yeah, thank you. So I have to share my screen. Can this be enabled? It was just showing up now. It's not. Oh yeah, thanks.
So you can share your screen.
Done. Can you see my screen, please?
No, sir, not yet.
Okay. Can you now see my screen, please?
Yes, sir, it is. Yes, yes, sir.
Okay. Thanks a lot. So my name is Satish. I'm from Reliance Jio. I've been introduced earlier, so we can get started. So when we talk about 6G, there are some pertinent questions to ask. There are learnings from 5G, and there are technologies which are fairly independent of 5G, which has to be looked at. So 5G as an anchor is one of the ways to look at 6G. Now, if we look at 5G, one of the key aspects to look at is the spectral efficiencies of 5G in comparison to 4G, and what 6G can offer with respect to 5G. There are issues of network costs. We will come to that. There are issues of spectrum, which influences the nature of the technology that will get into 6G. There's always a question of what AI can bring onto the table. There is also something that we will cover in this presentation. Then it's a matter of how do we put it all together. And there's a certain amount of realism that I've tried to bring in to this whole 6G discussion, primarily because we have had quite a bit of learning from the 5G deployment and other issues. Now, if you look at 5G, purely from a throughput apple-to-apple comparison, there's always a question mark of how much of gains it actually gives over LTE, because both of them are Ofdm technologies. And if you when I say apple-to-apple comparison, if you do a 100 megahertz 5G NR versus 100 megahertz, 20 megahertz into 5 carrier aggregated LTE comparisons, spectral efficiency wise or throughput wise, it's somewhere about 10%. This is always an arguable number, but then again, you even if you do optimize, I've seen numbers from 10% to 20%. 20% jump, even if you take a best case scenario, is not necessarily considered as a generation of wireless technology over an existing generation. So that's one of the key things to consider. And this is purely from apple to apple comparison. Now, if it is understood that even LTE can do massive MIMO, but it's not the most efficient, primarily because of multiple reasons. Because the handset penetration, which is already there, which may not necessarily support spatial diversity, and the nature of upgrades, the beamforming algorithms retrofitting into an existing deployment of 44R or 88R kind of a system. So there are quite a few issues. So it's more of a practical scenario that we are talking about. From a practical perspective, if we were to look at it, what is it that really makes 5G very different from LTE? In my view, that's going to be massive MIMO. The success of massive MIMO is very critical for the success of 5G. Else, it gets to be compared with LTE, and it's on the wrong footing, primarily from a business case perspective. Because from a business case perspective, if you start mapping the dollars onto the spectral efficiency, and that's how the business cases are built up, things may not necessarily add up substantially. And one has to understand that 5G is going to be deployed on a much higher spectrum band than LTE. So obviously the densification is much higher. So as an operator, if I can say, the order of magnitude of deployment of the number of radio access networks in comparison to LTE would be 1:5. If for every LTE one LTE base station, it is anticipated that one can have up to 5G NR base stations. So there's a cost rig up which is going in that direction as well. So you have a lot of base stations. The base station numbers are going up. Spectral efficiency is arguable unless and until you get the massive MIMO thing working. So this is where we are right now. This is the comparison basis for us to start thinking of 6G. Now, this being the scale or some kind of a benchmark or a yardstick, we look at other issues. Now, one of the key things that obviously, having discussed the spectral efficiency difference between LTE and 5G, 6G will have to bring an order of magnitude increase in terms of spectral efficiency. And to do that, if you look at most of the forums, there is more or less some kind of a general consensus that OTFS is going to be the new air interface over OFDM. Now, that is not the final thing. In order to achieve an order of magnitude spectral efficiency over and above, or a throughput efficiency over and above 5G, one will also have to have some kind of symbiotic radio. In the sense, unlike previous generations, till about 5G, when you had one primary air interface and that was more or less it. Here we need to have multiple mechanisms working in conjunction with each other. Now, for example, what we anticipate is OFDS being the primary or the anchor air interface. Around that, you build in some kind of a cognitive or intelligent spectrum sharing mechanisms. You build in the full duplex on and off. Full duplex is something that cannot always be triggered. It also is dependent on the handset capability and quite a few things. And the goodness of the equalization algorithm that is built in or accepted as part of the specification, that is something that has to be worked out. So there is a lot of trade-offs that comes into play here. You also have intelligent reflective surfaces or reconfiguration surfaces, as whatever it is called as. So primarily, these are glorified relays that help in assisting the primary base station and in trying to reach certain SINR objectives. So you can place these IRSs or RISs, as they're called in some other literature, in key positions, and they can coordinate with respect to the primary base station, and you really can have SANR gains. That is the whole objective. So they all have to work in conjunction if we really want to have some kind of a spectral efficiency, which is order of magnitude different from what we see in comparison between 4G and 5G. That's one of the key things that will decide the success of 6G. That has to be brought into the scheme of things very early on. That's one of our takes. There is another thing to look at, which is how many of these 5G use cases is really going to be part of the 5G deployment scenario. One has to really understand that 5G design has primarily been centered around what is called as enhanced mobile broadband, or EMBB. Now, once you build a system for broadband, then you're trying to fit in everything else into the scheme of things. Now you say, okay, I also need to have ultra low latency, then I need to accommodate edge, then I need to have machine type communication, billions of them playing around. So literally to the extent of 80% of your data that originates in a 5G network, fully mature 5G deployed network, could be around 80% of it coming from machine type devices. In such a scenario, the whole nature of the design of a network is very different. You're not trying to build a network for broadband and then trying to fit bursty traffic on top of it. So what typically happens, or what is going to happen for 5G deployments, is it is going to be EMBB centric. Then your MTC type or the IoT type networks is going to be an overlay. You're going to have some kind of an urban IoT which is built on top of 5G network, not necessarily tightly coupled or some such thing. If you look at ultra low latency, you are promised this remote surgery and all the stuff which is slowly fading. At least the hype is fading and reality is setting in. When you talk about ultra low latency, it's not just over the air interface latencies that you're talking about. You're talking about end-to-end latencies, and which is outside the purview of much of standards. It's all dependent on quite a few other things as well. So one really understands that ultra low latency use cases can benefit or can be aided by the right amount of breakout mechanisms, rather than fully focused on over the air round trip delay reduction. That is going to be very helpful. We did have breakout mechanisms in LTE, not very effective breakout mechanisms in 5G, but it is assumed that you have edge, which will actually act as a breakout point. But then edge itself is in the core network, so it's how much of you can take a guess how much of efficiency in terms of low latency it can offer is questionable. But then again, it also depends on the nature of the use case. So what we anticipate is there's going to be a spillover of what was anticipated in 5G as use cases, which could become, realistically, it could become the candidates for 6G. That is something that has to be kept in mind. So when 6G is designed, one really has to understand what is the nature of the use cases which are autonomous versus nature of use cases which are remote controlled. Now, if you look at a flow shop, if you look at industrial flow shops, if you look at the so-called self-driving cars, there's been a lot of pullback on the so-called expectations on the autonomous driving. Then again, we're talking about autonomous driving. Self-driving, autonomous driving does not necessarily need connectivity to the extent that it has been pushed in the press. So one has to scale back on some of these things. So one really has to understand what can work in an autonomous fashion and what really needs a remote control. Connectivity comes in when you want remote control. And if segments of industry relies heavily on autonomous control, then there is a mismatch in the early expectation itself. That has to be really considered in the design of autonomous versus remote control. And there is a trade-off between them. Not everything which is autonomous will not be dependent on remote control, or what where you see remote control is not 100% remote control, but has aspects of autonomousness built in. This is something that has to be understood from beginning, because this plays into the network design. And this is something that has to be taken into account from a 6G perspective, because in 5G, the expectation and the reality are far away. And the other key thing one has to look at is the network affordability. And this is one of the key factors that will have to play out in the 6G era. Now, if you look at 5G deployment, I told you there's an order of scale cost increase in deployment of 5G in comparison with LTE. These are figures which are publicly available. And one can see that there is almost a 100% increase in the network deployment cost in comparison with LTE. Optimized, non-optimized, I mean, there's always a trade-off. So, I mean, this is figurative, but one can easily imagine that this is almost double. It's double, yes, but then again, the demands on the backhaul, demands on the rest of the network efficiencies are also increased. So it is expected, GSMA says that it's going to take $1 trillion to have 5G coverage. This is in comparison to what we have as part of LTE coverage today. And that's going to be huge. There's always a question of where will the $1 trillion come in? Even in 5G, certain geographies will see rapid 5G deployments because there's money in certain geographies. And the rest of the geographies will be starved of 5G. And typically coming from a IMT 2030 perspective, IMT is a UN organization, by the way, and UN has a global mandate. Now, it is a sorry state of affairs if you end up seeing 5G deployments in concentrations of geographies and not necessarily reaching out to certain other geographies of the world. And that's going to be a sorry state of affairs. In 6G, this is something that has to be built in. There are ways of building, taking these things into account. Technologies are there which can really make the network cost come down. Just a comparison with respect to the cost of smartphones, or basically the phones. If you look at the phones, the prices of phones have been dropping very drastically, but the feature set has been increasing extraordinarily fast. The same has not necessarily been a trend in networks. And in networks, even in order of proportion, it is not true. So there is a serious discrepancy in terms of availability of technology. And one can easily suspect that it is the nature of the architecture of these networks that somehow tends to jack up the cost. Highly centralized networks, the way cellular networks are designed today, is one of the key factors why the cost goes up, substantially. And the nature of the security mechanism which is built in, and the very tight dependencies between the core network and the access network, as much as it was the intention not necessarily to tie them up tightly, it has ended up that way. You cannot have a access network without a core network. As much as the security functionalities are split in, and your access control itself is split in, so it is fairly tightly coupled. So those are the areas which one will really have to look at from a 6G perspective. So if cost is one of the factors, but then again, what are the other factors? There are certain intrinsic nature of the services that has to be considered. If you look at the intrinsic nature of densification, that is also one of the key factors that will influence your design of the network architecture going forward in 6G. If you look at the nature of service deployments, there's going to be a lot more private personal networks, enterprise networks, than in comparison with just the public cellular network deployment. So those are the ones which will really play out into the network architecture, which will be part of 6G. And this will demand different levels of data breakout points. And the nature of handling of data, control, security, everything will also have to be localized. And those are the factors which will have to be taken into account, or will greatly influence the nature of the 6G architecture which is to come. And yeah, of course, AI. Everybody expects AI to play a big role in 6G. Now, there is one thing which always has to be looked at is operators looking at an intelligent pipe, not necessarily a dumb pipe. So a cellular network has always been considered to be a pipe, dumb pipe. Of course, there are certain optimizations which are built into the network, which is self-serving. not necessarily serving applications, services, customers from an operator perspective, but it's how can I manage my networks better? Bring about certain operational expenditure optimizations in the play. That has been the viewpoint so far. But in 6G, if you want to look at intelligence as a service, intelligence as a service, in a sense, today we provide at the edge of 5G, we have something called as network exposure functions. So any application services can come and mate into a 5G network through these APIs. Now, it's not just these APIs. So typically what happens is you have a control plane and you have a data plane which is exposed to the outside world. You don't necessarily expose service APIs to the outside world. And specifically speaking, either security or some kind of intelligence APIs which are exposed to the outside world. That's not necessarily done. So going forward, there are quite a few opportunities with respect to having intelligence as a service. And that is something which will play out in 6G. And one of the key aspects which will be big in terms of 6G is going to be security, especially with 5G having become highly political and different geographies fighting it out. It's going to be big. Security is going to be big, and AI has a big role in terms of security. Why so much? So today, if you look at security paradigm in 3GPP, there is a security mechanism which looks at access networks. There are security mechanisms which look at the device side of things, and there is core network security. There is cloud security which is coming out from the cloud world, not necessarily from 3GPP. But if one were to have, as an operator, as a person who deploys this network, one were to have an end-to-end view of the security. This is very important because one really has to understand the threat origination point is not necessarily the point where the threat resides, and also not necessarily the point which the threat targets. Now, if you want, the threat can originate in a device, primarily intending to attack the core network. The threat can originate at the core network through some security gateway, but then intended to snoop into or look at certain devices. So this 360-degree viewpoint is something which is missing. The paradigm of security has to change in 6G from an end-to-end perspective, and not necessarily, at a point. That's how it has been so far. Unless and until you're talking about access during the initial access of the device, which is again.
Satish, there is a time check.
I'm
Can you
done.
close in
I'm
1
winding up.
minute? Yeah, thank you.
Perfect. So these are all the big things that will have to be taken into account. Spectrum is also one of the key aspects which should play out. But from TSDSI, we have a vision of 6G where we have charted out some kind of a plan, and this is the plan, and how this aligns with the rest of the global timelines. At some point in time, we, of course, will have to harmonize with ITU and 3GPP. So that is the viewpoint in which we worked out some timelines. And TSDSI has already started contributing to the IMT 2030 work. Primarily, we have 4 broad vision areas that we have focused on. We look at ubiquitous intelligent mobile connectivity as one of the key pillars. This is nothing but your extension of your cellular, normal understanding what your cellular technology is. But going beyond that, we have emphasized that there has to be technologies that will bridge the digital divide, and since bring the cost of the network down. There are technologies which are available, increase the throughput of the air interface, which will make it more affordable for per dollar that you spend on the spectrum purchase. There is that much more efficiency or business use case that one can see. So support technologies that can personalize localized data services or services. This is one of the key areas from a business viability perspective. There's a lot of opportunity to be had in personalization of services. The other key area is it's all going to be data centric. Who owns data? Is the enterprise willing to give his data to an operator, be located in an operator network location? How the data is traded? Who owns the data? Who is willing to give the data? Who's not willing to give the data? And how can a network be designed to accommodate multiple of these kind of scenarios? And it can go even to the personal level, the individual level as well. But I think at least in 6G, it will be more towards enterprises and private ownership. And this is the four key pillars from TSDSA perspective which we are pursuing. Thank you. I'm done.
Thank you, Satish. It's a wonderful talk, a very different perspective on 6G. Looking at the realities of 5G, there's a lot to learn from this. Now, given the paucity of time, what I would suggest is that we move on to the next session without too much spending too much time on questions. Mittalji, what is our schedule like?
Yeah, so we were to start the panel discussion at 11:45. So we are about 10 minutes late. So what we propose that the questions which are there in the Q&A box, we will take them up with the speakers and then send the replies to the people who have asked the questions. But because we are finishing the session, you can take one or two quick questions which are important to you, and we can finish in next 2-3 minutes. So we'll be full 10 minutes behind, but some 2-3 questions we want you can take.
Okay, let me see if there is any key question that I can. Just give me a moment. I'm just scrolling down. How do you see intelligent spectrum sharing different than spectrum sharing done today? There is one question.
So can I?
Yeah, please, Satish.
Yeah, so for 5G itself, we are struggling to get 100 megahertz of spectrum. India has still not seen spectrum auction, so there is still quite a bit of effort which has to go into getting spectrum for 5G, primarily because there are incumbents who are sitting on top of the spectrum. For 6G, if you're looking at other spectrum areas, it's not going to be easy. The same struggle will always continue. So other technologies will have to come into play, like spectrum sharing, secondary user of spectrum. There's a lot of other spectrum which incumbents may not necessarily be using. So there has to be technology solutions as well, as much as there is regulatory push. And that's one of the key points.
Thank you. I'll put one question to Ian. Ian, what is the take for some external agencies to join your alliance? I've seen some Japanese and maybe European entities part of your alliance. From India point of view, you have any views on that?
Yeah, sure. So, I mean, the sort of participation is open to organizations that have a interest in developing North American leadership in 6G, and that includes obviously companies from allied nations. But we have different levels of membership depending on the type of company. So the sort of top level is really for companies that are directly participating in the North American marketplace. But then we have the other levels which are open to broader companies. So if you're interested from an Indian company, then please do get in touch with the membership people. Thank you.
We'll do that. Thank you. With this, Mittalji, thank you, the speakers. We had really excellent talks. We are very happy to hear all these different views. Again, we thank you, all the three speakers. Let's move on to the next phase of the sessions. Mittalji, what's...
Yeah, I request Mr. Satish to hand over the session to the moderator, who is Professor Kiran. So Satish, can you...
Yeah, so I think the introductions are already available with Kiran. So maybe Kiran, you can go ahead with.
Yeah, Mr. Kiran can take over and introduce the speakers, and then Akanksha will throw up the slide for the speakers, and you can read the brief biodata, and then the session can start.
Okay, let me get started on that. We have a very good panel session now. Let me introduce the profiles of the panelists. We have Clara Lee, Anindya Saha, Devrati Sen, Ganesh Tyagarajan, Marty Latvaho, and we'll hopefully have a very engaging session now. Let me introduce briefly. Clara is a senior principal engineer with Standards division of Intel. She's been working on LTE and 5G on aspects related to air interface, radio networks, core and edge computing. She's currently leading the 6G efforts and she holds 28 patents. Great to have you with us, Clara. I'll move on to introduce Anindya Saha. He's the CTO of Sankhya Labs with plenty of years of experience. And he has led the development of baseband and RF subsystems of Sankhya's products in wireless comm. He holds many patents and publications in this domain. Welcome, Anindya. Next, I will introduce Devrati Sen. She is working on both wireless and optical communications as well as computing. She has 13 patents and published more than 100 papers in various conferences and journals. Welcome, Devrati.
Thank you.
We have Ganesh Tyagarajan. He is the CTO of MMRFIC Technology. With many years of experience in the device industry, he has a solid track record of delivering products in cellular and radar systems. He has 20 patents and many publications in the reputed conferences. Welcome, Ganesh, to this session.
Thank you, Professor Karan.
Finally, we have Matti Ratraho. Apologies if I didn't pronounce the name correctly. Matti is serving now the Academy of Finland as a professor, and is also the director for National 6G program. And his research interests are in mobile broadband communications, and he's also looking at 5G systems research. Matti has published more than 500 papers in the field of wireless communications. We're happy to have you here, Matti, with us.
Thank you, Kiran.
Great. So I think without losing much time, let's go ahead and get started with our Q&A. I have posed 9 questions, and we'll go round robin and take the views from the panelists. We don't have to follow any specific order. I will prompt, but feel free to raise your hand and let me know if you have to say something. We have a fairly.
Can I request all the panelists put on their video camera?
Tulji, can we get started?
Yeah, I just interrupted for people to put on their camera. That's all. You can please go ahead with your session. Yeah,
I'll get started with my first question for this round. What are the lessons from the ongoing 5G deployments, and how are we going to incorporate these learnings in defining 6G requirements? Clara wanted to address this question. Clara, please.
Okay, thank you, Karen. Yeah, so I can briefly address this question. So in 5G, we know so we further enhance more broadband, and another important aspect is to enable the verticals, which is trying to broaden the mobile service. So we do expect in 6G, we need to introduce new type of services that can further broaden the mobile industry, and so that the network is not just serving the connectivity, but also provide some value-added services. And also, if we look at 5G, there's a lot of in 5G we initiated the edge computing. We added the edge support, but we also noticed that because there is a decoupling between the mobile network and the edge, in the sense that the communication connection is established through control plane signaling, but the computing service is later transported through the user plane data pipes where the network is unaware. So this decoupling actually cause it could be. I hear some echo. I don't know if. Okay, let me try. So yeah, so this decoupling actually is one of the root blockers that prevent the large scale universal deployment of the edges. So if you see today's edge, it's mostly reside in the regional edge locations or reside in a private network. But if we're talking about massive universal edge deployment, there is still a long way to go. So I think in 6G, we need to address this issue by having a more tight coupling between the communication link establishment with the computing service establishment. And from the radio part, in 5G we have the millimeter wave, and we also learned a lot from the millimeter wave deployment on the blockage issue, on the beam management issue. So I think moving forward in 6G, all those issues need to be addressed, and also especially if in 6G we are considering even higher frequency band. So the issues that we observed in millimeter band will be more severe. So those are the issues we need to we learn from 5G and we want to address in 6G. Also in 5G, we also have we see the trend of network cloudification. In fact, the 5G core network is built on SPA, and it's natively deployable in a cloud. So in fact, in 6G, we expect the same trend will continue, and the network will be even further cloudified. And this type of network cloudification actually gives us an opportunity to further think of what of services we can provide from the network. Can we so we can actually this type of cloudification actually enables us to have a kind of tighter coupling between communication and computing, and having the computing as a service and provided by network. So yeah, so that's I think that those are the learnings we had from 5G, and what we would expect 6G to build on top of the learnings. Yeah. I think that's Kiran, back to you. Yeah.
You are on mute, probably, Kiran. We are not able to hear you.
Hello?
Yeah, now it's okay.
Yeah. So, any other views from the panelists on this question? Feel free to speak up.
So this is Matti. So maybe
If
I
not,
would
we'll go to the next question. Yeah, Matti, please.
So
Go
one
ahead.
thing that we have seen happening already with 5G is that these local deployments, like local 5G in Japan and these private 5G networks, for example, in Germany and other countries, they are starting to pick up, and we believe that that trend is one of the key drivers towards 6G. So the need for these localized services is really emerging trend, and I think in regulatory regime we should do everything possible to enable and support that kind of development rather than trying to hinder it. So that's one thing that I think we should follow very closely.
Thank you, Marty. I think this is very relevant for the Indian context also, not only in other parts. We will take these inputs, very much. Any other input here? Okay, if not, we'll move to the second question. What kind of innovation is required to achieve universal coverage? That is, achieving reliable, high-speed internet independent of user location. Specifically, whether we are traveling by air, train, or located in a remote area, how do we achieve universal connectivity and the quality of connection? We'll start with Anindya, Devrati, followed by Matty. Anindya, please.
Yeah, thanks, Professor Kiran. Thanks for the introduction. So I think one of the things which was already mentioned in one of the presentations earlier today was the advent or the introduction of more things or more concepts from a cognitive radio. I think so far, if you look at till 5G, I think it was more, I would say it was more. Uh, there was very little amount of sensing in terms of the communication. But now, one of the things that we really need is that more intelligent communication to achieve coverage. And that also needs us to sense the environment, sense the radio environment. And one of the things which we believe is once we sense the radio environment, and then if we can go to what we call as hyper-personalized network, that is one of the vision that we have in 6G, to build a waveform, which is actually kind of customized based on a user's radio environment or the user's. That is something which can enable, which could. I would say this was something which would give a good framework for achieving universal coverage. However, achieving that is not very straightforward. It involves multiple things. If you look at the end-to-end network, right from the infrastructure to the user equipment, it involves the entire signal processing chain, the network layers, the RF, everything. So what we feel is that this needs a little bit holistic approach where you look at it end-to-end and design waveforms which can optimize based on a set of cost functions, and those cost functions could be not only speed but also reliability. I mean, sometimes what we would have seen is that achieving both simultaneously may not be very easy to do, and that is where engineering trade-offs need to be made. So what we feel is that such kind of a framework where we can look at the whole radio environment parameters, as a stuff, and optimize it for a set of cost functions which is really required, could be data rate, or this could be one of the something which could be a starting point to achieve universal coverage.
Thank you, Anindya, very good comments. Food for thought. Let's hear from Devrati.
Hello. So, in my viewpoint, in order to get universal coverage, you need to have the real-time location information, and that should be equally available in all parts of the distributed network. And network expected to be a very intelligent one compared to the 5G and 5G beyond. And we can actually augment this real information of the localization integrated on it. AI is going to play a very important role in this aspect. And the last one that I feel is that quantum communication will be also coming up to resolve the issues of having the uniformity in terms of the data rate, quality of service throughout the network, irrespective of the location information. So quantum is not only the design of this web form that Anindya was telling. So if it is driven from the transceiver design aspect itself, so quantum communication will come up with a new type of the receiver design implementing the effect of your real-time location informations and all other quality of services bringing into the fact. So the design aspect of the whole transceiver design, starting from the PHY layer to the MAC and going above in the network perspective also, will bring a new era.
Thank you,
Can I also
Matty.
can I also comment on this?
Yes, please. You next. Yeah.
I really think that this is big time, let's say, business model challenge. It's a challenge of how to arrange backhauling connectivity. It's not so much on what type of really cool 6G front haul air interface we are able to come up with. It's backhauling problem. As it is a backhauling problem, it's in the end of the day, it's really a financial challenge, if nothing else. And so it's business model backhauling challenge, and there is now satellite industry have been trying to come to the play and do it in a different way. And as we know, satellite is never going to produce the capacity, overall capacity required in the systems, and also it's going to be awfully expensive solution. So many times these universal connectivity challenges are related to remote areas, often poor countries and areas. So we must think about affordable level of communications. We are not probably looking at the latest state of the art within the next 10, 15 years, but something rather robust and affordable, which is going to solve some of the problems. Having that in mind, we actually have been playing with an idea to have, let's say, local sweet spots with, you can think them as private networks, locally optimized and locally tailored for service needs that are required in different settlements or villages or you name it, with very limited or no backhauling connection at all. And in that way, the local communities can have the services they need, they can improve the qualities of their lives, and they can have lots of modern services to really make their lives far better. So that's one way to look at it, rather than trying to have democratized rights for everybody to have a super fast speeds towards internet.
Thank you. Thank you, Matty. I think this is a very important issue, especially in countries like India, large countries with very large rural areas. Okay, let's move to some related question. Considering the fact that SpaceX and many others are already offering SATCOM services, what kind of attraction do you see for 3GPP based NTN systems? Alternatively, will 6G include seamless integration between SATCOM and terrestrial networks? We'll start with Ganeshan.
Thank you, Professor Kren. I kind of want to connect what Matthew talked about in the previous question and this one. So in my opinion, all these services are complementary and they will coexist. Like an example, what we are looking at today is the Wi-Fi and 3GPP trying to coexist together. For the advantages for the user, end of the day, the user is the customer and customer is the king, right? So if we can provide a better service for the customer by whatever the service available near to him, and we should probably make that enabled. And that's what, in my opinion, 6G would do. That basically it will seamlessly integrate all these services. And who will do that integration is some kind of edge device, what Matthew talked about. The edge device kind of looks at all the services available in the neighborhood for the user and then picks the right one for making that particular service successful in terms of he or she can be gained in terms of data rate or the cost or even the coverage. I think that kind of total integrated service providing is what probably will make sense for the 6G, in my opinion.
Thank you, Ganesh. Any other views on this?
Yeah, Professor Kiran, I wanted to speak about this.
Please.
So basically, yeah, one of the things I felt is, I mean, this is a personal view, is that yes, a lot of good work is happening in 3GPP for NTN systems. of course, I think all of us know it has started a little bit late, and I think that is where I felt that maybe the adoption of that might be a little bit hampered if you look at the market wise. How much of traction it will gain, I don't know, because if it is late, and the other problem which has been in the satellite industry is that people have been having a lot of fragmented proprietary solutions, but then there have been some good standard solutions as well. So actually, looking at the timelines of 3GPP, and once you go into a meeting, you always find that there are not there are insufficient TU units. Uh, what I felt would have been maybe a better approach was to probably start with an idea of interworking the existing technologies rather than trying to, again, I mean, here also I see that we are trying to, or at least 3GP is trying to retrofit, I would say, the NR waveform, customize it for the satellite. To certain extent, it is possible, but I found that a lot of existing technologies, DVB S2, S2X, RCS2, are pretty good, are pretty wonderful. I mean, they have addressed a lot of problems over a long period of time. So I would think that if it might have been a better approach, first develop an interworking with existing solutions, and to top it all, the problem that Satish mentioned, a lot of these satellite operators already have existing infrastructure. To re-engineer that for a totally new standard again will take time, and that I think is going to definitely delay the adoption. That is my view on the 3GPP NTN. Although I mean, I believe it's a step in the right direction, but it is more aimed towards expanding the coverage of the terrestrial cellular network to this to include the satellite and high altitude communication systems. But the standalone communication systems which are already there, they should not be left out. They should also be brought into the ambit, is what I strongly feel. Thank you.
Thank you. And this requires probably an hour discussion, so I don't want to put more questions to your comments, but I will leave it at that. Shall we move to the next question? Next question is URL LLC specifications are available, but the killer applications are not in sight yet. What kind of latency targets do you foresee in 6G? Do you have specific applications in mind for 6G URLLC? Clara is willing to take this question. Clara?
Yeah. So so it's in general, in generation, we would expect to see some further enhancement or kind of order of magnitude improvement on the latency and throughput. So in 5G, we have the 1 millisecond latency, interface latency. It is small already. But if you compare the interface 1 millisecond latency versus the other communication technologies latency, for example, the Ethernet latency, it is still a very big number, this 1 millisecond. And so I do expect the community will still strive to further reduce latency to a much lower value. So that we could potentially match the latency of a wireline communication and potentially using wireless to support many wireline use cases that today we have. For example, support some type of jointly jointly computing between device and network. So this relies on lower latency, and ideally we could achieve the latency that a wireline can achieve. But it is a hard problem. It's not that the latency reduction is not just by improving the throughput, we can automatically reduce latency. Because it's not only about the transmission slot reduction, but it's more about to reduce the processing time at the receiver side and transmission side. So this is very hard to do, and we do need a lot of effort for them to look at technology like further parallelization or pipelining to reduce the processing latency. And also, our target is not only to reduce the interface latency, but also to reduce end-to-end latency, meaning that the networking part and the computing part at the server side. So this latency issue need to be taken by a holistic view. It's not only interface improvement, but also we need to look at the architecture improvement. I think one of the speaker in the previous session talk about breakout. Can we do RAM breakout in the 6G? I think that is a very valid point that potentially we could reduce the forwarding latency caused by core network, and also the propagation latency caused by the transport network. Yeah. So in summary, I do think in 6G we want to strive for a lower latency. This is a KPI that a generation would shoot for. And there's many use cases. Just look at the wireline communication use cases. And I do think the community could work together to have to strive for lower latency.
Just to bring clarity, when you talk about wireline latency, do you mean wireline latency, let's say around millimeter wave frequencies, as opposed to wireline latency in sub-6 frequencies? They're probably different things. So you have any comment on that?
By wireline technology, I mean, for example, Ethernet, Ethernet is actually a good example. We know Ethernet latency is in the order of a microsecond. We don't expect the wireless communication can really reach the microsecond level latency, but we could try to further reduce. So in terms of the carrier frequency, I don't have a particular carrier frequency in mind. It could be in the lower band, but it could be in the higher frequency band. But I do recognize that in the high frequency band, because of the shorter symbol duration, we expect a shorter symbol duration and shorter slot duration. It may be easier to achieve low latency. But the more important part is really how to reduce the processing time, because by simply reducing the slot duration or symbol duration, but keep the TX arcs processing time, we couldn't really reduce latency. So the most important part is to reduce the processing time and to look at the overall end-to-end latency, end-to-end architecture to reduce the intermediate nodes.
Thank you. If there are no further comments on that, I'll go to the next question. Applications of AML, we talk about it quite a bit. What kind of problems AML will solve at physical layer and max scheduling? I'll start with Matty, followed by Anindya, Clara, and Devrati. Matty first.
Thank you. I think Juho Lee already touched this question in his nice keynote talk, and I very much share his view on that most likely in the specifications of future standards, they will just enable utilizing some of the machine learning algorithms without specifying exact mechanisms, what to do, how to do. And although some some companies even have suggested complete design for overall air interface by AI algorithms. I don't think it's really feasible as we understand that how dynamically changing the radio environment is due to mobility and constantly changing interference situation and changing traffic situation, etc., etc. I think in the end of the day, the capabilities to learn from the radio and interference environment will be somewhat limited. You can learn about statistics, you can learn about typical behavior in certain part of the city block, or how the traffic forms there, and what is the mobility, and so forth and so forth. And you can start to make predictive models out of that and try to do your best to predictively estimate what's happening and speed up the learning algorithms, convergence times, etc. So lots of possibilities for, if you learn the statistics, even a little bit of the channel, to improve greatly the performance of different channel estimation algorithms and procedures. For example, what is currently missing still to great extent is accurate positioning to be incorporated to mobile communication systems with using the same communication signals without introducing too much extra signaling. And in positioning type of applications, I think learning from the radio environment is really crucial. And in those types of applications, I think machine learning can help quite a bit.
Thanks, you, Matty. Good comments. Let's go to Anindya.
Yeah, I think Matty has covered most of the, I would say, the space of what people are really thinking of AI/ML. I think I think he's already covered lot of stuff for the physical layer. If I look at the interaction with the MAC layer, there was always the concept of cross-layer optimization which was existing, and now what people are doing is to do a cross-layer optimization between the MAC and Phi by bringing in a lot of observability. I think one of the key things which I find very important for AI/ML to succeed is to bring in a lot of observability, a lot of observable parameters in the design of the RAN network. Probably whatever exists today may be sufficient, may not be sufficient. I don't know. It looks insufficient, but then a lot of that is going to help, or all of that is actually a fundamental requirement to doing this. We can also, for a moment think of very simple case. Let's say I want some way to estimate my channel, and based on that, I want to change even my pilot locations. Now, how frequently do I want to do that? Is that feasible or not? Those are other issues to think of. But you can go to a large extent. I mean, if you imagine the the extent to which things can be done, there is no end. I mean, I can change my pilot position, pilot density, also, in turn helping with my throughput and all that, based on how the channel conditions are. But then, do I really want to do it or now? I think those trade-offs we need to see. The other thing which I a little bit worry about when we talk of AML optimization is also the amount of energy one needs to spend doing these learning. While we are talking of going to 6G, more sustainable communication, the amount of energy we spend in creating this model, running these deep learning algorithms, they should not overpower or increase the OpEx bill for the operator so much so that it overall it does not give benefit. So I feel those are also things which one should keep in mind while implementing. These applications, or at least whatever we want to do in AML, it needs to be really low footprint, needs to be really energy efficient, while giving the benefits. So I feel we need to take a cautious approach. There are infinite possibilities, but you know, uh, need to be careful. That's all.
Thank you, Anindya. I mean, it's a question of whether you want to improve 10% of the network performance as opposed to solve some difficult problem. One has to see. Clara, please.
Yeah. So I think today we already have some application of AI/ML for the network optimization. I think next step, a more important question, a more interesting question is how much we can apply AI/ML to help with the interface. I think on this aspect, in 3GP release 18, there is already a discussion, for example, to use auto-encoder type of transmission reception to help CSR feedback. And also there's a application of AI/ML to address beam management. So I think all of discussion are still in the very kind of preliminary stage. We do need a very thorough evaluation to considering the aspect like the additional capacity, what are the gains, and power consumption, and also how robust the AI/ML algorithm is to the channel variations and environmental change. So yeah, so in general, we should look at the areas that we expect big gains as compared to today's model-based approach. Yeah, so I think this is a very exciting topic. If we can prove that this works, and this may fundamentally change how we design the future interface. But before that, we do need a lot of evaluation and verification to really kind of validate the potential usage. Yeah, I think that's all for my comment.
Thank you, Clara. Finally, Devrati on this.
Yeah, thank you, Kiran. So there are several portions in the physical layer design where the application of the AI will be inevitable. For example, if you see about the virtual large massive MIMO structure with the virtual antenna arrays, and if you are trying to design the whole system in an efficient fashion with to improve the QoS, or actually you try to control the number of the antenna selections from this virtual antenna array, in order to make the transmission energy efficient. So AI will be only the option to go ahead with it. If you bring the concept of the beamforming on the top of this massive distributed array, so then it brings in another level of complications in the signal processing domain. And another good application that is going to merge most probably the application of the optical communication and the wireless. For example, if you see today, we are planning to add the VLC over the drones for the wireless communication. We are trying to go ahead with the radio over the fibers. And so the multiple complicated modulation schemes, we are applying to go ahead from the optical domain to the applied on the wireless parts. So questions will be something like this. I mean, what will be the optimal way of transforming the signal from the optical to the wireless domain? How the channel estimations can be done in such scenarios when the dynamical selection between the different signal processing blocks are going on. And if you come to the, not only from the channel estimation beamforming part, if you come to the, even the filter designs, for example, the structure of the IIR and the FIR simple filters for such kind of the complicated systems that can be redesigned by the neural networks. So people are seeing it in a completely different form. The angle of viewing the system design itself is continuously changing. The way you will view it is getting completely changed. So there is a high chance of application of the AI, and AI will be a good friend of us in coming future. Thank you.
Thank you, Devrati. We'll have to speed up a little bit. We still have 4 questions to go, and only 10 minutes left. What are our views on network slicing and its evolution towards 6G? Anindya?
I think network slicing. I mean, I'm just drawing from continuing from the same place where I think Satish made a mention in his presentation. See, today most of the systems are being designed, and even probably the waveform is designed with EMBB as a use case. It almost looks like network slicing, and also the waveform changes or the modification suggested looks a little bit like an afterthought. And I think that probably needs to improve a little bit more. I don't think it is still optimal. Uh, at least this is what I feel from a waveform design perspective. There could be better waveforms designed for the same MMTC, application. The other thought I have on network slicing is the implementation. And although it's a great concept and we all love it, how feasible it is to implement with a cloudified environment with all the latencies, end-to-end latencies, how easy it is to do this is something which we need to see. Both on the infrastructure side as well as the user equipment side. Um, mm, what I feel, which that I feel it needs to happen going towards 6G, is that we need to probably see a little bit more meat into how the slicing function really gives a significant benefit. I would say a KPI benefit uh, compared to what it is today, and how easy it is to implement. I feel the implementation aspect to some extent has been considered, but when we look at it as an end-to-end network, I feel some of those aspects have still need a little bit more refinement than what it has been. So I feel network slicing, it's a great concept, but then how many people are really going to deploy it? Let's say that the same operator, how many slices is he going to give and under what condition? How does the geography introduce? How does the backhaul introduce? All those variables make this very, very challenging to implement. So I feel some of those are things which the next generation waveform, whatever next G or 6G, needs to consider seriously for it to be really deployed effectively.
Thank you, Aninda. Any other views on that? Quick views? If not, we'll move to the next question. How do you see Wi-Fi 6 and 5G evolve towards 6G? Clara, followed by Ganesh.
Yeah, so I think the Wi-Fi community already started working on the next generation Wi-Fi, the Wi-Fi 7. So what I want to mention is I do think the Wi-Fi and the 6G, 5G, those are the complementary to each other. For example, in 4G we have the IoT Wi-Fi interworking. In 5G, we have the network natively support non-3GPP access. In this case, Wi-Fi connect to 3GPP core network, and also there is support on traffic steering because between Wi-Fi and 5G connections, the so-called ATSS. I do expect in 6G we will have similar discussions to incorporate Wi-Fi connection as part of the overall 6G system, so that those two technologies can be complementary to each other and address, for example, different scenarios. Yeah, so I do expect the technology for all of them would continue to evolve and work together. Yeah.
Thank you, Clara. Ganesh?
Yeah, I do agree with Clara's statement about that these two technologies coexisting with each other. In fact, in my opinion, the Wi-Fi integration already started with LTE. Today, if you see your voice call, we don't know whether it goes through the RAN or through the Wi-Fi. I mean, they have seamlessly, operators have integrated already. And that same thing will continue for data services as well. I mean, in 5G, it's pretty much possible because of the non-terrestrial network integration is very much done. And also the coexistence in the unlicensed band is also being explored for the 5G, right? So that way, the integration is already started, in my opinion, and 6G will continue this, take it to the next level. I kind of want to connect this to the previous question in terms of the network slicing. Network slicing is just one level of abstraction. I think the next level of abstraction will go towards a service slicing, in my opinion. For example, today Vodafone has a frequency which is conducive for doing URLLC, and he can always cooperate with other users and then take all the URLC users to that carrier, and then they can coordinate all the calls. And that kind of service slicing is what it will evolve into in the 6G.
Interesting. Thank you. Two more questions to go, and I will move to massive MTC. These are still seem to be very early days. What would be the key drivers that would enable widespread adoption of extreme massive connectivity? Matty first, followed by Devrati and Ganesh. Matty?
Okay, so 5G introduced two new directions: this ultra reliable low latency communications and this massive MTC, and neither of these has really picked up yet, and we have to understand and try to analyze why this has happened. Massive MTC, it's really the kind of market segment and product segment that it's meant for is relatively, let's say, cheap products. So transceivers has to be very low cost, easy to install, and it has to be available for multiple different purposes. And in that respect, I think we should try to think about what would be, so to say, holistic kind of deployment scenarios for trying to push it forward. And let's start to look at what is the most holistic, instead of going to, let's say, industrial segment or cooperation oriented and MNOs oriented world. Why don't we just start to think about plain customers, us, everybody, and try to come up with some holistic models and really nice, cool applications which are cheap and easy to install to make it really happen. So that hasn't been looked at yet at all, and most likely to go to these let's say big scale customers, so any man from the street could buy those devices, install them, use them. That really would push the prices down of the transceivers and would force also the network providers to come up with easy to install solutions. So that might be one way to really push it forward.
Thank you, Matty. It's a difficult one. We can have a long discussion, but we'll move fast on this. Next, Devrati.
Yeah, so there are multiple key enablers for this MTC to fly. First of all, that in 5G we have seen that already 5G NR has started talking about the vertical aware solutions. So 6G should take it very seriously. What do I mean by vertical aware solutions? Means suppose tomorrow in the field of automotive, the radar-based communication systems, we will be having the multiple solutions, say for V2V or V2X. Some service providers will be having their own kind of map with the different roads and traffic plans. And so this different kind of the service providers, they should be having a seamless connectivity between them. So the vertical aware solutions will be asking for the modular network design also. And the second one I can actually mention about the energy efficiency definitely. So where we can talk about the energy harvesting and energy efficient transmission mechanisms, and which also again will require about the knowledge of your environment. So constant energy awareness with respect to your radio environment is expected to happen. When we are talking about the massive connectivity, so efficiency is coming into a big problem there. So efficient massive connectivity with the real-time location information once again will be very important, especially for the critical massive structures. For example, in the LTE, we are talking about the handshaking, right? Multiple grants we give for the handshaking, four-way handshaking we give. So such kind of the applications we cannot even think of for this massive connectivity. powered by the AI and machine learning has to happen because intelligence will be becoming a big important issue there to control your energy efficiency as well as the complexity, because you will be seeing the multiple kind of the requirements are coming up because machines will be of not of similar type there. And I feel that also there's edge computing that today we are also coming up with. That will also play a very big role to control the last minute connections to the whole network. And finally, the security. Security has to happen because that security is not only from the higher layers. The file security today, we have not explored those areas explicitly to be introduced and integrated to our commercial network. But 6G should take the file security very seriously, and it should be integrated in the standards to ensure the security, especially for this critical MTC and also the cellular communication.
Thank you, Ganesh.
So actually, MMTC has not taken off well as of now. But I think, in my opinion, there are three killer applications waiting to happen. One, monitoring of vital signs from the human body. And if you can imagine, if you can just measure only body temperature and blood oxygen level and constantly monitor in the entire neighborhood, you can avoid pandemic spread kind of situations. One. And you can probably lead to privacy issues and other things. But today, anyway, Google knows wherever you go. I mean, privacy is already compromised in many places. And if the medical insurance company gives incentive for people which allows to share this data, with the people allow the company to take the data from the device, I think that is something people will be willing to. If there is an incentive for people to do that. And the second killer application is constant monitoring of the drives and equipments in the industrial IoT kind of scenario for preventive maintenance, right? And there is also a huge amount of data, and then you can just periodically collect data for monitoring. It could be even in a private network, but that is something which is doable. And the third thing is energy monitoring and giving constant feedback to the generation and distribution system, where we can try to work towards the zero carbon carbon neutrality kind of service. I think these are the three killer apps where I think MMTC will actually will provide a lot of advantage.
Thank you, Ganesh. Good views. The difficulty lies in convincing different verticals to adopt. I think that's going to take time. I think in time it probably will happen. Finally, any thoughts on 6G spectrum allocation, Matty?
So this spectrum regulation is really critical for the next generation, and whatever decisions are made in allocating new parts of spectrum, those will remain there for 25, 30 years or whatever. So it's really long-lasting decisions, and the key question is that is the world really, or the society really ready for accepting the necessary changes taking place everywhere under the names of, for example, sustainability, and how we have to try to use all possible ways to improve or foster those goals. And so far, we have trusted to mobile network operators to build sufficient coverage to develop these services that we are enjoying today. And of course, they are building and the networks wherever the revenue models are supporting those plans. There are many cases and places where there is no foreseen revenue for classic mobile network operators, or very minimal. So for example, the governments should have a role in that, or maybe some other new types of players. So that is really critical discussion. And like I already earlier pointed out, this role of local networks, that kind of developments in the future, we have to make sure that these new possibilities are made possible in spectrum regulation. So the ownership of spectrum is really critical. And the key question is that do we need some new players besides MNOs in the future? There are different views on that. But I think if we just simply think how important wireless connectivity is becoming in running societies even today, and more so in the future, it's really critical question, and the consequences will last there for a very long time. So, not an easy question to answer.
Thank you, Matty. Finally, we'll take views from Devrati and close this Q&A. Thank you. Yeah, Devrati, you have something to say on this? Or?
Yeah, so going ahead, the way the spectrum is released for 5G, where we have seen that up to 100 gigahertz flat worldwide almost, we are accepting that the application will be going ahead. Cellular will be in the 28, 30 gigahertz, but automotive world, they will be in the 77 to 81. And going ahead, the way the research is going on from there, we are slowly moving towards that terahertz, expecting that terahertz will be fulfilling the expectation of higher and higher data rate and power hungry as well as the data hungry applications that are coming up. But frankly speaking, I mean, seeing the way the whole spectrum allotment is going ahead worldwide, and asking about the fact whether the very high frequency applications and transmissions will be good for the human as well as the animal world, whether we are going to actually do something really good for the humankind or really going to go ahead with something giving an odd effect on ourselves. I mean, maybe the lower terahertz communication range will be there, but very high terahertz range is expected to be, I mean, the chances to come for a spectrum allocation will be very less. That's my personal opinion.
Thank you.
But it will go slow. It may not be so fast.
Yeah, thank you. And Mittalji, what is the next step for us? I think we pretty much reached the end.
So if the panel discussion is over, then the schedule was that we will have a 15 minutes Q&A and a concluding remarks, but we are already overshot by about 8 minutes.
Yeah.
So it is up to you to decide whether we can skip the Q&A and answer the questions on email.
Yeah. So my suggestion is that we'll take all questions and send to the panelists and the parties, share with them and get their responses offline. So my apologies, we just couldn't manage this time effectively, but I believe we had a pretty good session today. So I would like to close my part of this session, and Mittalji, you can take over. Thank you.
Yeah. Thank you, Professor Kiran. And so, because we already run out of time, so I must thank everybody, all the distinguished panelists, speakers, and our co-chairs for running the session. There are really new things which came out, a lot of new ideas for 6G thoughts which have come out, and it will trigger, the thought process and the further development of 6G. The lead taken in Atis in US for North American standards is really appreciated, and then the methodical way in which they are proceeding is visible in the presentation. And so I think this session we have the takeaway is that there are a lot of ponderables in 6G. Where are in 5G? What are the lessons we have learned? How to take them into 6G? And what new can be done in 6G to cover the scenarios, some of the application scenarios which are indicated, and there may be many more which will emerge when the discussions progresses. So I think with that, and thanking everybody, and not the least our organizing team and IT team. I cannot name all of them. There are a number of people who have been behind this, the executive committee, the organizing committee, and our IT team. So thank you everybody for making this session possible, and all the speakers and panelists once again for sharing their valuable thoughts. So with that, probably we can close the session. Thank you very much once again. We will be sending the questions to the panelists and the speakers with a request to kindly answer whenever time permits, so that we can share with the people who have asked the questions. Thank you very much.
Okay,
Thank you.
Thank you all.
Bye.
Thank you.
Thank
Bye-bye.
you for the opportunity. Thank you.
Thank you.
Thank you.
Thank you, everyone. I'm just closing the